First day of the semester. Usually that one. Thank you very much. Good morning, everybody, and welcome to EE 555. This is the Broadband Network Architecture, which is the second course in the series of computer networks after EE 450. Let's go over some of the administrative information before we start with the overview. Again, the course is EE 555. It's offered in two sessions. Session 1 is Tuesday and Thursdays, this session from 7:30 to 8:50 in All of Engineering 132. There is another session which is Tuesdays and Thursdays, 6 to 7:20 p.m. It's in room WPH. I have no idea what WPH stands for, but it's at the end of the campus. WPH 102. Now, the capacity of this room is 40 students. So what I'm trying to tell you is that if you are not able to make the morning session, try to attend the evening session. However, there is no guarantee that you will find a seat because the room is a small room. It's only 40. So we will see how that will go. Now, the discussion hours is on Wednesday, 8:30 and 9:20 to 9:20 a.m. on All of Engineering 122. This is the studio just outside this studio. And I'm trying to get another discussion session in the evening so that it will give you a chance to attend either the morning session or the afternoon session or the evening session. But it's not yet done, so I will keep you up to date. My name is Professor Zahid. Some of you might have taken EE 450 with me. Some of you might not. How many of you did not take EE 450 with me? Did not. Why? No, just joking. Okay, so my name is Professor Zahid. My office is PHE, Powell Hall of Engineering, 418, and this is the office number. My office hours is Tuesdays and Thursdays from 9 to 10:30, which means after the class, from 12:30 to 1:30, from 5 to 5:30, 7:30 to 8, and I might stay after 8 p.m. if you need me. But provided that you walk with me to the parking lot. At night is dangerous. You need to walk with me. So you will be acting as my bodyguard. I will also schedule some extra office hours before the midterm on Fridays and on Saturdays. Well, I will tell you about that later on when the time comes. This is my email, azahid@usc.edu, and the website. Everybody got access to the website? Everybody? Okay, good. So it's uscden.net. The course prerequisite is EE 503. It used to be called EE 465. They combined two courses, EE 465 and 464, to become EE 503. Everybody here has taken EE 503? Everybody? Okay, good. EE 503, which is called the probabilistic methods in computer system modeling or probability theory. I'm not sure what is the name of the course right now. And of course, EE 450 is the introduction to computer networks. More important to me than either one of these things is your passion and dedication to the course. You need to love the area of networking to be able to succeed in this course. We are going to have two teaching assistants. The first teaching assistant, who is the best, no question about it, and he's present at the back. Could you stand up, please, so that everybody will see you? Mr. Angelos Lazares. You all know Angelos, for those of you who took 450. For those of you who did not take 450 with me, this is the best. Angelos Lazares, his email is this. His office is PHE 330, which is in the same building as I am, but in the third floor. His office hours is Wednesday 9:30 to 10:30, and on a Friday between 11 to noon. His responsibility will include conducting a weekly discussion session and maintaining the course website, conducting the office hours, 2 hours per week. And again, I am sure that before the midterm or before the final, he will schedule some extra office hours for you guys. The assisting students with their homeworks, with their projects, simulations, and so on and so forth, all of these things. All the emails concerning the homework should be addressed to the TA, to Angelos, and CC to me. The reason that I need to your homeworks to be CC to me is that I need to make sure that he Angelos respond in a timely fashion, and he always does. And also, if I need to add a couple of comments to his response, I will be able to do that. Clear? Most of the time, based on the experience of E450, I did not need to add any comments. His comments were extremely, extremely crispy and very clear, very clear. So, but just in case that I need to add a couple of, as they say, my 2 cents thoughts in it, you need to CC me your question. And I will also ask Angelos, when he replies to you, he include me in his reply, so that I need to make sure that everything goes well. The other teaching assistant, I have no idea how to pronounce his name, but I will call him Nachi. It's very difficult for me. Teaching assistant, Mr. Nachi, whatever. He is currently in India. He will be back later this week, so I will introduce you to him next week. He is also a PhD student, a very nice guy, although I haven't met him yet, but based on what other people tell me, that he is a very nice and smart kid. His email is this. His office and office hours, of course, will be determined. His office hours will not overlap with my office hours and will not overlap with Angelo's office hours, so that you will have a chance to see any one of us during the week. His responsibilities are the same as the responsibilities of Angelos. What we are going to be doing is that we are going to be dividing the class into 2 parts. Part of it will be handled by Angelos, and the other part will be handled by Nachis. Both TAs will be available to all the students during their office hours. During their office hours, both TAs will be available to all students. But during email, if you want to write email, you need to write email to your designated TA. I will be posting the list of the students who are going to be, whose Angelos will be their designated TA, and those whose Nachis will be their designated TAs. But you can see both of them during their office hours. In other words, during their office hours, they are not going to tell you, are you in my group or in not my group? They will be answering all the questions as they come. Okay. We are going to have three graders. This might change depending on their availability, but they will be posted on why the email does not show up here? Does it show in your screen? In your charts? What happened here? Okay, anyway, I need to see what happened here. Their responsibility is grading your homeworks, your simulations, not your projects, and so on and so forth. These are the responsibilities of the TAs. The midterm and the final, of course, you know that these will be my responsibility. I will be grading the midterms and the final. All the emails concerning the homework grading, not the homework solution, but the homework grading, needs to be addressed to your grader. The grader will be writing his or her initials on your homework, and you will be able to contact them if you do have any questions. And of course, you CC it to me or CC it to the TA. The course workload, we are going to have a midterm on a Friday, not on a Tuesday or a Thursday, but on a Friday, March 7th. You will have 2 choices or 2 time slots, just like 450, if you remember. We are going to have it from 4 to 6 p.m. and 6 to 8 p.m. The 4 to 6 to p.m. is your session. The 6 to 8 is the evening session. However, if you cannot make it during this session, you can take it through this session. So I will be flexible in assigning in allowing you to attend any one of these. Of course, the room is to be determined. They don't set up the room right now. The final exam is going to be on a Thursday, May 8th. The final exam is set by the school, Thursday, May 8th. Now, they set it at 7 to 9 p.m., but I will also have two time slots. One of them is from 5 to 7 p.m., and the other one is from 7 to 9 p.m. So whichever time slots you would like, it's fine with me. We are going to have weekly homeworks, term papers, simulations, extra credits, just like we had in 450, the same thing in here. There is absolutely no makeup exams, no matter what your reasons are. So if you are not able to attend the midterm or the final during those days, drop the class from the start. I do not give makeup exams. Roughly 5 to 6 homeworks will be assigned, and they need to be submitted during the lecture that they are due, or before that, not after that. So for example, if the homework is due today, you need to submit your homework during the class. If you cannot attend the class, you need to submit it before the class. You can go to my office and just slip it underneath my door. That will be fine. I will accept it. Clear? Do not submit late homeworks. I do not accept late homeworks. For DEN students, if there are any DEN students, you need to email your homework to denhw@usc.edu. The last bullet is very important. You need to understand carefully. The midterm solutions will be posted, and your graded midterms will be returned to you. However, neither the final exam nor the solutions of the final exam will be posted. Of course, you are most welcome to come to my office to review your final exam and to look at the solutions. You are welcome to do that. But I do not return. I need to keep some souvenir. At the end of the class, I need to leave some souvenir. That souvenir is your final exam. The grading policies is midterm is 40%, final is 40%, homeworks and term paper or the project is 10% each, extra credits to be added to your midterms, and so on and so forth. Grading scales, I don't go by a scale whatsoever. I don't go by a curve, so you already know that. This from 80 to 100 is A minus to A plus, and there is no A plus. I don't think USC has A plus. But in any case, B minus to B plus is 65 to 79, 50 to 64, and so on and so forth. Hopefully all of you will be in this category here. Okay. The course, by the way, EE 555 is a challenging course. It's not an easy course. I cannot say, like I said in 450, I say that it was a fun class and stuff like that. This one might not be that much fun. So it's a challenging class. We need to work, all of us, including my team and you. We need to work very hard throughout the semester to be able to survive or to excel in this class. This class is heavily targeting technologies. In other words, it's heavily targeting those people who wants to work in the industry. Are you following me on that? It's not targeting those of you who want, for example, to go into an extra 4 or 5 years to go for a PhD degree. This is targeting this time. In other words, as soon as you graduate, you would like to have an opportunity to find a job with the major or leading companies in networking. Clear? So, the topics that we are going to be covering, of course, not in that order. We will be looking at switches and routers, architecture, high-speed switches and router design. We will look at several broadband technologies, including ATM, MPLS, gigabit Ethernet, carrier Ethernet, virtual LANs, and so on and so forth. We are going to be looking at optical networking technologies such as SONET. SONET, by the way, you notice a lot of these jargon that we will be studying throughout the semester. We need to understand what they stand for. SONET stands for the synchronous optical network. WDM stands for wavelength division multiplexing. PON stands for the passive optical network. OTN stands for the optical transport network, etc. All of these optical network technologies, we will be studying them in detail. This constitutes, as we'll see in just a second in our overview, the core of broadband networks, the one that have a huge bandwidth to be able to carry the heavy traffic that is being imposed onto the internet. A major portion of our class will be studying quality of service architecture and building blocks. No more the best effort, remember the best effort service model? No more the best effort service model. We need to understand mechanisms to provide for what? Quality of services, clear quality of services. Trying to achieve what the application or what the services is asking for. Different services ask for different requirements. We will see how the network provide these quality of services. We will study a lot of protocols for multimedia, including multicasting, voice over IP, streaming audio, streaming videos, and so on and so forth throughout the semester. These topics, again, as I told you, you will not see it in a specific class, but we will cover it throughout the semester. Now, you might also be covering some of these in CS 555. Sorry, CS 551, just in case you take this class. We will also be looking at broadband technologies for the last mile. Last mile means what? The access network. The network that connects the customer network or the customer premises equipment to the service provider network. We will study the ADSL, the cable, the Ethernet, the 802.11, the WiMAX, and so on and so forth. And we will put together the mechanism or the architecture to integrate both the IP, the Internet Protocol, with the optical metro and long-haul networks that we will discuss in a minute or shortly. Clear? Okay. Now, included in all of these requirements that you need to be able to understand queuing modeling. Clear? Now, some of you, how many of you have taken 503 with Professor Sunas? Okay. Now, I assume that he did cover some queuing models in there. How many of you did not take the class with? Okay, the rest. Now, what we are going to do, so first of all, the T.A. Angelos in particular, he will be spending a couple of discussion sessions reviewing some queuing models in there. And I also might schedule some extra classes on a Friday, maybe this Friday or next Friday, to review some queuing models for you. Because again, as I told you, some of you might have taken 503 with a professor who did not emphasize the queuing modelings and so on and so forth. So you will be a little bit of, I don't want to say disadvantage, but you might be a little bit behind in the topic. So we will see how that goes. It's in any case, we will review the material also in the class just to make sure that you are ready to handle this topic. Clear? Now, there is no, any questions on this? There is no single reference book or, sorry, there is no single textbook that will cover all of these topics that we will be talking about. It's just not possible. So these are a list of reference texts. Most of them are available in the library. If you need to borrow some of them from my office, you are welcome to do that. Probably you will find most of them on the web. If you know, depends on your ingenuity. You can find soft copies of all of these textbooks on the web. Clear? Okay, but basically, again, basically they are all reference texts. When we assign homeworks, I will be posting the problem statement in there. So I will not refer to a book. I will be posting the problems or scanning it from the book so that you will have it. Clear? Any questions on this? Clear to everybody from the start? Okay, good. So let's start looking at overview. Just an overview. Overview came up to be 80 charts, 80 pages. This overview is supposed to be only 10 pages. It came to be 80 pages. This is an overview. What does overview mean? No details. The details will be coming throughout the semester. This is just an overview about the architecture of the network currently and what has changed in the architecture of the internet in particular, and so on and so forth. Get to be familiar with the buzzwords, a little bit familiar with the buzzwords. Okay, what is the keyword is what? What is broadband? When you say broadband, when you talk about the word broadband, we need to understand what it means. Basically, what it means is what? High bandwidth. We have a high bandwidth. Bandwidth means what? Means the capacity of what? Of carrying traffic from millions and millions of users. Currently, there are about 5 billion users using the internet. So we are talking about high bandwidth. High bandwidth, when you talk about access, when we say high-speed access, access means what? As we'll see in just a second, that's the network that connects the customer premises to the what? To the service provider network. Clear? Service provider network. We are talking about roughly from 256 kilobits per second. This one, by the way, does not seem to be very what? A very high bandwidth. But it's still regarded as what? As a broadband. Still regarded as a broadband. Now, you need to understand, as we'll see in just a second, always the bottleneck will be in the access network, not in the core network. In the core network, there will be abundance of what? Bandwidth. The bottleneck in the end-to-end connections will be on the access network. So we are talking about 256 kilobits per second to roughly 100 megabits per second. This one even will change very quickly with the introduction of a new generation of wireless LANs, the 802.11n, the 802.11ac, which can support higher rates than 100 megabits per second. I just wrote it there. Then we have what is known as the huge core bandwidth, the core, in the core network. We'll see what the difference between the access and the core in just a second. These are what huge pipes, examples of which is the OC48. OC stands for optical carrier. That's the standard, the optical standard. OC48, which is referred to as the SONET, 2.5 gigabits per second. Notice, by the way, the 2.5 gigabits per second is not also what? Not that much. So these are just examples. OC192, which is a higher rates at 10 gigabits per second. OC768, which is currently under deployment. OC678, which is what? 40 gigabits per second. 1 to 10 gigabits per second Ethernet in the metro network or in the core network. Ethernet, when we studied it in the 450, what was it? It was a technology that is used for a local area network. Now they are deploying Ethernet in the what? In the metro network or in the core network. We will see that in just a second. 10 gigabits per second Ethernet in the metro or the core network. 10G to 100G in the dense wavelength division multiplexing. DWDM stands dense wavelength division multiplexing in the optical transport network. Okay, this is a broadband. Why do we need a broadband? We need a broadband to support services, what was referred to as a what? A triple play. For those of you who play baseball, you should know what a triple play is. For those of you who do not, this does not make any sense. But the triple play is what is the convert services is the high-speed data, the voice, and the video. The high-speed data and the voice and the video. Streaming video, streaming audios, and so on and so forth. Now, of course, another services on the rise is all types of what? Mobile services, as taking the technology by storm. Clear, providing access to what? Access to all of these services via your iPhone or iPad and so on and so forth. Okay, now why broadband? Why do we need a broadband? We need a broadband because the telecommunication service providers, the AT&T, the Verizons, and so on and so forth, they determine that they are not going to be able to what? To make lots of money or to generate revenues by just simply providing conventional type services. What are the conventional type services? Conventional type services is accessing the web, email, for example, or file transfer, and so on and so forth. They found out that these types of services are not going to be what? Able to generate large what? Large sum of revenues. They needed to what? Bring some more excitement to the end user. More excitement means what? Providing all types of what? All types of services that requires extremely higher what? Higher bandwidth. Clear? Extremely higher bandwidth. So they decided that the services that they can provide, if you look at, let me jump a little bit so that you can see what I'm talking about. Look at this one here. Look at this. This one is not clear here. These are the conventional telecommunication services, including the voice, the internet access, and so on and so forth. And these are the value-added services. The value-added services, including what? The web hosting, the multimedia conferences, video, audio on demand, high-definition TV, video on a PC, online gaming. All of these are not conventional services, These are what is known as what? Value-added services. They needed to add all of these services to attract a new set of what? A new set of customers and to generate what? To generate more revenue. Clear, generate. Those here are not able to what? To generate that much revenue here. Okay. So the customers were demanding lower costs, a single service offering. They did not want different networks. Customer does not want a network for voice, network for video, network for data. They wanted all what? Integrated together. So they wanted what? Single service offering, along with the high cost to access the backbone network, means most service providers are not generating enough revenues. This is what I just said a moment ago. To increase their broadband penetration, they need to lower their prices because of the competition here. Home networks are no longer what? Simple. They are getting more sophisticated with all of the additions of what? They are no longer just a single PC per connection. You do have what? Game consoles, we do have TV set-tops, and so on. So all of these gadgets that you use at home, they require what? Much higher bandwidth. Applications, again, as I told you, the gaming, the video on demand, the IPTV, the gambling, and so on and so forth. All of these, the customers are becoming what? Tech savvy. They know a little bit about what? Technology. So they are asking for more types of services. The demand for greater bandwidth has increased. Also, there is a need for service differentiation. What does that mean? Service differentiation means what? Not all of these services are asking for the same requirements. The network needs to be able to differentiate between these services. Some services requires, for example, minimum latency. Latency means what? Delay. Some of them requires maximum throughput, and so on and so forth. All of these are what? All of these are allowing the service provider to provide what? To provide what is known as a tiered bandwidth. Tiered bandwidth means what? Means separate. The service that they offer you, they call it, for example, the bronze service, the silver service, the gold service. Every type of service levels is different based on the requirement or based on the types of services that you are asking. And of course, the competition also always results in what? Reducing the cost of delivery of all of these type services to the end user. These, again, a list of the some broadband services that are currently in use, the high-speed internet services, the point-to-point or multi-point, VPN. VPN stands for anybody? VPN stands for what? Virtual private network. We'll talk about that in detail shortly. Virtual private network, voice services, again, audio conferences, video, voice over IP, and so on and so forth. Video services, video broadcast, video on demand, online gaming, and so on and so forth. All of these are regarded as what? As broadband services that require larger what? That requires larger bandwidth. Now, let's look at how we are going to divide the network, the broadband network, into components. Now, first of all, we have the user. The user could be a what? A residential user, or he could be a what? A corporate user. SME stands for what? Small to medium enterprise network. Small to medium enterprise. SME stands for what? Small to medium enterprise network. These are companies that probably they have what? 100 employees, 100 to 200 employees are regarded as SME. SOHO stands for what? Small office, home office. Small office, SOHO, small office, home office. These are smaller businesses, or even some businesses that you run at home. This is the user network. Clear? Now we will be looking at both types of customers, residential customers and corporate customers as we move along. Difference between them, of course, is that a corporate customer is willing or is able to pay more to get what? More bandwidth to the corporation, more than the residential customer. So keep that in mind. We need to separate them clearly. Then we do have the access network. One more time. What is the access network? Access network is the network that connects the user network with the service provider. You notice I always say service provider. I did not say internet service provider. I just said what? Service provider. Different types of services. Internet service provider is only one type of service. Clear? So I don't want you to be confused with the word internet service provider and what? Service provider. Clear? So the network that connects the user network with the service provider network is what is known as the access network. Now, what technologies are being used? What technology are being used is both wireless and wired. The wired access, we have the DSL. DSL stands for what? The digital subscriber line. Cable access, we do have FTTH. FTTH stands fiber to the home. Fiber to the home, extending the fiber all the way to the home. Now, there's a variation of this. We will see them in just a second. We will have what is known as the fiber to the curb or fiber to the premises and so on and so forth. We have many possibilities in here. We also have the PON. PON stands for what? The passive optical network. Again, I'll explain that to you in just a second. All of these are called what? Wired access. They are within what? The transmission is within a physical medium. Clear? Either cable, either coaxial cable or optical fiber. Or in the case of DSL, through what? Through copper wire. Clear? Through copper wire. And then we do have the what? The wireless access. Wireless access, the BWA. BWA stands for the broadband wireless access. Broadband wireless access. We do have the WiMAX. The WiMAX it's similar to WLAN. It's similar to the Wi-Fi for the local area network, but this one covers what? Covers a metropolitan area network. The WiMAX, the Wi-Fi, the 3G, the 4G, cellular, and so on and so forth. All of these are what are referred to as the wireless access. Clear? Okay. Now, the metro or the core. The metro and the core. These are the what, as I will show in just a second. The core, of course, is the transport network. Transport network is the one that is going to carry the heavy traffic around what? Across the what? Across the globe, as we'll see in just a second. Metro is a network that covers what? A metropolitan area network. Clear? Okay, in here, the media is strictly what? Optical fiber. All of them uses what? Optical fiber. In other words, we are not talking about what? We are not talking about ADSL or cable, and so it's optical fiber. Different types of technologies that are used is the SONET or the SDH. SONET stands for the synchronous optical network. Synchronous optical network. SDH stands for the synchronous digital hierarchy. This is the European standard. This is the US standard. Of course, in our semester, we will only concentrate on the SONET. The European, who cares? They are weird anyway. So we will be discussing the SONET in this class. The CWDM, CWDM stands for the coarse wavelength division multiplexing, and the DWDM stands for the dense wave division multiplexing. Again, I will give you an overview of these. The details are later on. This is basically what? Multiplexing several wavelengths on a single fiber, rather than having what? A single wavelength on multiple fibers. This is what? Multiplexing multiple wavelengths on a single fiber. Dense means what? Large number of wavelengths. Coarse means what? Small number of wavelengths, as we'll see. Then there is the ATM. ATM stands for the asynchronous transfer mode. IP, of course, you know that is the Internet Protocol. MPLS, which is going to be our focus also in this course. MPLS stands for the what? The multi-protocol label switching. The difference between MPLS and then the IP, as we'll see shortly, is that in the IP, when those routers route or forward the packets, they depend on what? They depend on the IP address that you will find it in the header of the packet. That address, we refer to it as what? Destination IP address. In MPLS, we will see that that address will be replaced by just a label. It becomes what? Much faster, and we will see that we can allow the routing table to be shortened based on what? Based on the labels rather than based on the addresses, IP addresses. And of course, Ethernet. This is a new thing. Ethernet, again, historically was a technology that is used primarily for the local area network. Currently, the Ethernet is being deployed both in the metro network and in the what? In the core network. Again, as I will show you shortly, the difference between them. And of course, the back end is where all types of servers are located. The back end is where those, in other words, those users are trying to access those servers. Content servers, web hosting servers, video servers, authentication servers, and so on. So you can see it in this diagram, simple diagram. This is the core network. This is the address. Aggregation. The aggregation. What does aggregation means? Aggregation means what? All the traffic from multiple users will be aggregated at a point where we are going to refer to it as the edge of the network. All the intelligence, we want to put it on the what? Edge. In the core, we want to make the core a dump network. What dump means? Stupid. You follow me on that? What does that mean when I say dump network? In the core, I want the core just to be basically a transport mechanism. transporting all of these packets very quickly. All the intelligence, for example, providing all of these quality of services and so on and so forth, management of the network, we want to leave it at the edge rather than in the what? In the core, so that we make what? We make the transport of the packets much faster. Clear? We will see that. So aggregation, whenever you see aggregation, it means what? It means that it's combining traffic from multiple users through the use of what? Multiplexing or concentration of traffic to a better use or a more efficient use of the bandwidth available in the metro and the core network. Clear so far? Now, we will study each one of these networks separately so that you can see it in rather detail. Now, for the residential, remember, again, as I told you, residential is different than the corporate users. Residentials, most of the connectivity services is internet access, informations, games, and so on and so forth. To corporate networking, what does it mean? You can stay at home and you are a residential user, but you want access to your corporate network. Corporate network is where you are working. And instead of what? Instead of commuting to, or instead of driving to the corporation, you can sit at home and access the corporation resources from home. This is what is known as telecommuting. Not all companies allow that, but some companies do allow that. I experienced some companies before, and it was fun to sit at home and just access the resources at the corporation or at work from home. Local content, residential customers are interested in local news on demand, video on demand, and so on and so forth. Peer-to-peer communications, video conferencing, IP telephony, multiplayer games, and so on and so forth. All of these are residential service requirements. Each of these services, as we'll see shortly, requires different or demand different requirements. So that's what we referred to a moment ago as differentiated services, providing different qualities for different types of services. Now, this is again the overview of the broadband access. One more time, the access is connecting the user to the service provider network. The wired, again, the ADSL. VDSL stands for the very high data rate subscriber loop, digital subscriber loop, very high. And we'll see that in just a second. How is that done? ADSL stands for what? Asymmetric digital subscriber line. ADSL stands for asymmetric digital subscriber line. Cable access is HFC. HFC stands for hybrid fiber cable. Hybrid fiber cable means what? Some part of it is fiber, some part of it is cable, as I will show in just a second. The fiber access, again, as I told you, fiber to the home, fiber to the curb. C stands for curb. Fiber to the curb. The PON, the passive optical network, and so on and so forth. The wireless access, again, the Wi-Fi 802.11a, B, G, N, AC, all of these types of versions of 802.11. The WiMAX is the IEEE 802.16. Again, IEEE stands for the Institute of Electrical and Electronic Engineers. Cellulars, the 3G, the 4G, and so on and so forth. All of these that we will be studying throughout the semester. Let's take a simple example, ADSL. What do we have? This is two customers. This is their, we have seen this, by the way, in EE450. Those of you who have taken the class with me must have seen this. But for those of you who have not, we will see that in just a second. These are ADSL users or subscribers using the same telephone line. Same telephone line. Now, on the telephone line can support both voice and what? Data. Do you see this line? This line has what? Voice and data in it. When it comes to the service provider network, the service provider network will take the voice to the what? To the PSTN. PSTN stands for what? The public switch telephone network. The public switch telephone network. So the voice will go through the what? The voice band filters. What kind of filters are these? Low pass filters. They are low pass filters. Why? Because voice covers what? Limited bandwidth between 0 to 4 kilohertz. So this is the voice band filters. Take it all the way to the what? To the PSTN through the voice carrier system. Telephone network. The PSTN, the public switch telephone network. The data will come. You notice, by the way, the data from here is coming to here. The data from here is coming to here. And what will they do? They will get what? Multiplex. This is what is known as what? DSP. DSLAM. DSLAM stands for what? DSL, Digital Subscriber Line Access Multiplexer. What is the purpose of this? The purpose of this is to provide for traffic aggregation. One more time, what is aggregation means? Aggregation means what? Combining the traffic. Clear? Combining the traffic. This type of multiplexer or concentrator is referred to as what? Statistical multiplexer. Do you still remember this from 450 or not? Statistical multiplexer. What is statistical multiplexer? Tells you. It tells you that the output rate is less than the sum of the what? The input rates. Is less than the sum of the input rates. Why is that? One more time. Because you are taking into account that not all the inputs are going to be what? Active at the same time. Do you still remember this or not? Tell me the truth. I can handle the truth. Do you still remember this from EE450? In EE450, the statistical multiplexer is going to be assigning the bandwidth on a per demand basis. He is taking into account not all of what? Users, not all of these users are going to be what? Active at the same time. So for example, let's assume that we do have 10 users. Let's assume that we do have 10 users. And each one of them, when generating traffic, generate traffic at a rate of what? 1 megabits per second. What is the aggregate traffic? The aggregate traffic will be what? 10 megabits per second. It's what? 1 times 10. Clear so far. But the concentrator rate or the multiplexer rate will be what? Less than 10 megabits per second. For example, it will be what? 5 megabits per second. Why? Because we are taking into account that what? That those users are going to be what? Are not going to be all active at the same time. This is what is referred to as what? Oversubscribed. Oversubscribed means what? Means you have more subscribers, more than your what? Your ability, more than your bandwidth. Did you understand? Oversubscribed means what? It's like, listen to this. It's like this room has a capacity of what? 70 students, but I allow what? 80 students to register in the class. I say what? Oversubscribed. Oversubscribed because I'm taking into account that not all of the students will show up in the morning because they are still asleep. It's very early in the morning. Did you understand what oversubscribed means? Oversubscribed means what? Means you add subscribers more their bandwidth or their aggregation is more than what is available. But you are taking into account that they are not going to be what? All active at the same time. Okay, so they are going to be what? They are going to be aggregated. The traffic will be aggregated in here, and it will be what? It will be sent to a switch, an Ethernet switch or an ATM switch, which will connect to a what? A router. The router will take you to the what? Data tap networks, the internet service provider. You notice I did not call this one service. What is this one? This one is called ADSL service provider. This one is called what? ISP, which is what? Internet service provider. These are two different things. This is providing you access to the internet. This one is providing you service, which is called what? ADSL service. Clear? On a single line, you are going to be able to support both voice and data. Again, we will look at this in detail later on. We also cover this in 450, but just in case that you took the class with some other professor who did not discuss this, we will have a chance to discuss it. Now, the hybrid fiber cable or the cable access, what do we see? We also have seen this in 450. Let's review it quickly. What do we have here? We have a cable head end. This is the cable company. All of these are, do you see those? All of these are what is known as fiber, the feeder fiber, high bandwidth fiber. They extended all the way to the what? All the way to the curb, if you would like, or to the community of residential customer. From residential customers, you are going to get what? All of these are what now? These are coaxial cable. These are coaxial cable. Now, what are these? Let's see if you still remember. Do you still remember what are these? No response. What are these? Do you see those triangles? These are amplifiers along the way to make sure that the signal does not degrade just because you are living in a residential place which is a little bit farther from the cable end, does not mean that you are going to get a worse quality. Because there are amplifiers along the way. There are amplifiers along the way. To all types of neighborhoods, all types of neighborhoods. This is, for example, neighborhood area B, area C, area A, about roughly 500 homes pass through a single cable. This is the diagram that shows you the detail. We do have at home a PC. You are going to be connected to a cable modem through the HFC network. HFC, again, the hybrid fiber cable to the what? To the cable head end. This is the cable head end. We have the cable modem, the telecommunication server here. The cable modem, telecommunication server here. The cable router, if you would like, and then he will take you to a switch. This switch, by the way, is the same as this switch. So when we talk about this switch here, it's the same as this switch. By the way, connected to this switch are all types of servers, DHCP server. DHCP stands for what? Dynamic Host Configuration Protocol Server. Yes, that's the one that will assign you what? IP addresses, that will assign you what? Address for the default router. It will assign you address for your default DNS server. It will assign you the subnet mask. Do you still remember this? All of these are located here. All types of what? Web servers or DNS servers and so on and so forth. Local caching. What does local caching means? Local caching means what? Means it will cache some of the what? Some of the content which is located deep into the internet. It will locate it or cache it locally so that when you request it, you will get it what? Sooner rather than what? Later. Always remember the major point, which is what? The deeper you penetrate into the internet, the delay will go what? Will go up. If you can get the content that you are looking for closer to your point or closer to your home, it will become faster. This one, this router, do you see this router? This router is the same as this router here. Will take you to the what? To the rest of the world. Clear? Okay. Again, details, we will study it later on. All of these, again, is the access. Now, fiber to the curb. Let's understand what fiber to the curb means. This is the core network. Now, here we do have a what? A fiber node. This is the what? This is the service provider office. The service provider office. He will extend a fiber all the way from this point, all the way to the curb, all the way to the curb. This is the curb. These are the residentials. These are the homes and homes. A fiber, feeder fiber, all the way to the curb. Curb means what? Do you follow what a curb means? Curb means what? Some point at what? In the residential community. And then from the curb, he is going to extend copper wire. These are all what? Copper wires. They are not what? They are not fiber. They are copper wires. Similar to these copper wires. But the difference between this one and this one is that in here, all of this, all the way to the service provider are what? Copper. In here, the copper wire is only from where? From the residential to the what? To the curb. Which means what? Long copper wires or short copper wires? You are losing me here? You are losing me here. I can tell you are losing me here. Concentrate. Can you concentrate a little bit? In ADSL, these are what? Copper wires all the way to the what? To the service provider office. There is no fiber. In here, from the service provider office, we extend fiber all the way to the what? To the curb. This is the fiber. And only the remaining short distances are what? Are copper wires. Clear? That's what is referred to as what? VDSL. VDSL stands for what? Very high rate digital subscriber line. Why is it very high rate? It is very high rate because the length of the copper wire is what? It's very short. Are you following me or not? It's very short. Now, in this case, how many optical transceivers do we need? Oh, transceivers means what? Transmitter, receiver. Transceivers is the abbreviation of transmitter and receiver. How many of them do we need? Look at the diagram and tell me how many transceivers do we need? We need only 2 transceivers, optical transceivers. Clear? Why? Because this is the only feeder, the only optical fiber. These are not optical fibers. Are you following me or not? Okay. However, in this case here, this is not a pure optical access solution. Why it is not a pure optical access? It's not a pure optical access solution because these are what? Copper wires. Which means what? These are going to be behaving as the bottleneck. Are you following or not? Because they are not going to be able to provide you with what? Extremely higher rates. This one, the VDSL, roughly what? 50 megabits per second. Clear? Compare it with what? With ADSL. ADSL on the downlink is roughly what? Max 8 megabits per second. What is D/L stands for? Downlink. Downlink means what? From the service provider to the what?
The time
to
is 11
the
o'clock.
customer network. Clear? Down. Again, you notice I did not say internet service provider. I said what? Service provider. Clear? ADSL is not an internet service provider. It's a service provider. Clear? Providing services to the service called what? ADSL service. You see the comparison? 8 megabits per second compared to what? 50 megabits per second. Why is this one higher? Why is this one higher? Is this one higher because the length of the copper wire is what? Shorter. The shorter the copper wire, the length of the copper wire, the higher the rate that we can send in it. Clear? No response. Clear? Okay, this is called what? Fiber to the curb. Okay, let's see this one. Fiber to the home or fiber to the premises. Premises means what? Residential building which has several units. Premises means what? Residential building that has several units. Let's see if you can tell me here. This is implementing a point to multi-point topology. What is a point to multi? Where is the point here? Can you show me what is the point? The point is the service provider office. Clear? Multi-point to all residentials. Now what are we extending? We are extending fibers all the way to where? To the home. All the way to the home. Clear? So if we do have end customers, if we do have end users, how many optical transceivers do we need? 2N. Did you answer where the 2N came from? The 2N. Did you answer where the 2N came from? How many users do we have? N users. Each one needs to have a what? An optical transceiver. Optical transceiver means what? Optical transmitter, optical receiver. Clear? And this one also needs to have what? 2 to the N. Why? Because these are what? These are point to what? Multi-point. They are not shared. These are not shared. And that's why it says what? It's a complex and costly to maintain. Because you are going to have multiple fibers. Clear? But this scheme, again, as I told you, this one is the one that will provide you with the maximum bandwidth. Why? Because the fiber is going all the way to your what? To your home. Clear? Okay. Let's understand the PON, which is the passive optical network. Let's see if you can follow all of this, by the way, in detail later on. This is just an overview. Let's see if you can understand the passive optical network, which is the one that is most widely used currently. Currently is the one that's most widely used. The passive optical network. I'm going to what? Extend the fiber all the way to the what? All to the way to the curb. This is a splitter. There is a splitter in here, a passive splitter. Yes? And from this point, I'm going to what? Split the fiber. In other words, look, concentrate on what I mean by that. All of these in here, all the traffic in here will be going to be split in what? To all of these users. And allowing what? Every user to what? To only take the traffic that is destined to it. In other words, on the downlink, do I have a broadcast? Do I have a broadcast on the downlink? A broadcast means what? This is exactly similar. Let's see if you still remember. In the Ethernet, remember the Ethernet? When you are connected to the network, when you are transmitting, when a node is transmitting something, all the other nodes, all the other what? NIC cards. NIC stands for what? Network interface cards. All of them will receive every transmission, but they are going to be what? Filtering all the traffic away except for that traffic that is what? Destined to it. Did you get this or not? Did you get this or not? Tell me, why do we need N+1 optical transceivers? Why do we need N+1 optical transceivers? How many optical transceiver does the service provider need? He only needs one. So from the service provider point of view, this one, this one is much more efficient to him to implement his network. All what he needs is is one optical transceiver as opposed to how many optical transceivers here? Multiple of them. Did you understand what I just said or not? Yes or no? You are losing me? Okay. So we have what? One optical transceiver in here. This is a passive. A passive means what? The traffic in here is going to be split into what? All of these. When split, what does it mean? You are only going to reduce the power of each one of them, but it's the same content. It's the same content. And in here, another splitter. Do you see this other splitter? We'll split it to what? All the homes. Every one of them will only select what? Will only select the traffic that is destined to that home. All the others will be what? Rejected. Clear? Clear? Okay. Now, how about the uplink? How about the uplink? The uplink, we do have a problem. Why do we have a problem here? Can you tell me why do we have a problem? On the uplink. Uplink means what? From the user back to the what? Back to the service provider. On the uplink, there is a what? A shared media. There is a shared media. They are going, see if this one is transmitting, this one is transmitting, this one is transmitting. In here, they are going to share it. Which means what? There will be a what? There will be a collision. Are you following me on that? So on the uplink, they are going to use some kind of what? A time-slotted mechanism. The service provider will provide them with different time slots, non-overlapping time slots that allow every user to transmit during what? During their own what? Their own time slots. Clear? Clear? Now, later on when we study also wavelength division multiplexing, we will see that each one of these users can transmit at a separate wavelength. At a separate wavelength. So that even though we have a shared media, but there will be no what? There will be no collision because they are going to use different what? Different wavelengths. Clear? We'll see that later on. Clear so far? Yes or no? This, again, the detail later on. But do you see the difference between this one and the previous two? This one and this one? This one is what? A single fiber, but these are what? These are copper wires. Clear? Copper wires. This one is what? Multiple fibers all the way to the what? To the home. This one is a what? Is a single fiber where it's going to be what? Split. This is called a passive splitter. Why do we call it a passive? A passive means what? The optical signal is not going to be converted back to what? Electrical signal. A device is called active if what? If you are going to convert electrical to optical, electrical, optical, and so on and so on. Passive means what? You are just going to split the optical signal. Clear? Clear? Oh, this is again the PON architecture, like I was just telling you about, extending fiber, and then what? Splitters all the way to the what? To the homes, and so on and so on. We will study this later on in detail. These were the what? The wired access. Now the wireless access, the one that you are familiar with, is the what? Is the Wi-Fi. Explosion, by the way, in the industry, in the Wi-Fi industry, is unprecedented. Unprecedented. Clear? Right now, everywhere you go, and you will see what? You will see access point. AP stands for what? AP stands for what? Access points. Clear? Access point. So we do have in the Wi-Fi, we do have what? An infrastructure-based versus what is known as an ad hoc. In an ad hoc, there is no access points. There is no access points, so they are going to be what? Able to communicate with each other, the wireless units. In the wireless, in the infrastructure base, the wireless units will be talking with the access point, and the access points are connected via a wired network. Most of the time, it's an Ethernet type network. Clear? Clear? Again, we will study this later on in detail when we get to the wireless broadband. The currently, by the way, it's the 802.11a/g, providing for 54 megabits per second access rate. Okay, the 802.11n provides all the way to roughly 200 to 400 megabits per second. This is through the use of what is known as MIMO. What is MIMO, anybody? Multiple input, multiple output. You do have multiple antennas so that these will provide for what cancellations of any multi-path fadings and so on and so forth, allows you to get this. And then the new generation, the 802.11ac, the goal is roughly what? Roughly to go all the way to what? 1 gigabits per second. Clear? That's unheard of. These rates are unheard of. But the penalty is what? As the rate becomes higher and higher, what will become smaller and smaller? The coverage. The coverage will become what? Shorter and shorter. Clear? The coverage will become shorter and shorter. I will talk about this in rather some detail later on. The WiMAX, the architecture, the WiMAX, which is the Metropolitan Wireless Network, allow you to what? Allow you to access the all types of what? All types of services, but at distances. Here we are talking about roughly what? Roughly 5 kilometers or 5 miles from your home, for example, or from your hotspots. By the way, in a hotspot, this is a cafe, for example. You do have a what? You do have a Wi-Fi allowing what? Your PCs to communicate with the access point, and then the access point is connected to what? It's connected to the tower via what? Via a wireless connection, WiMAX. See, what is the difference between this one and this one? In here, the access points are connected via what? A wired connection. A wired connection. Here you could have a what? Here you could have, for example, a router connected to a what? A cable modem, for example, or ADSL modem out to the outside world. Clear? Clear? Here. How are you accessing? This is a cafe. Let's say Starbucks in here. Yes? Yes? This is you. This is the customer communicating with what? With an access point. Yes? And the access point is communicating with a what? With a base station or tower in here. Yes? Via wireless link. This is a wireless link as well. Clear? But here we are not talking about what? 10 meter or 20 meter and so on. We are talking about roughly what? 5 miles. Allowing you to access the what? Allowing you to access the internet via this. This is similar, by the way. The idea is similar to the idea that when you take an airplane, if you are in the airplane, did you ask yourself how you are able to make phone calls or to make what? Access the internet? Anybody has tried it? Anybody in the airplane? Have you been in an airplane? Yes? Some airlines are providing for internet access. Yes or no? Did you ask yourself how that is done? Your laptops, for example, in the airplane is communicating with what? With an access point in the airplane. In the airplane, the access point in the airplane, and then the access point is communicating on the downlink with what? With all of these cellular towers, big towers. Are you communicating with those towers on the earth? Clear? Allowing you to make phone calls, allowing you to access the internet or in the airplane. Again, different customers, different some corporate, by the way, business access. If they don't have cable access in there, they can access via wireless. Everything. This is what is known as the wireless, the WiMAX architecture, the IEEE 802.16, and we will cover this again later on. Now, this is all the access. This is all the access technologies, which means one more time, it is our network that connects the customer network to the what? Service provider. So right now we are at the service provider. At the service provider, by the way, this is what is referred to as the what? The POP. Anybody? POP stands for what? No mom, just POP. The point of presence. This is what? This is a switch where all traffic is going, all traffic from different customers is going to be collected and aggregated. It's going to be collected and aggregated. Question, do we have only one pop? We have multiple pops. We have multiple pops nearer to the what? To the customers in every area. Clear? Those pops, then they need to be connected together. Those pops, those point of presence, they need to be what? Connected together. That connection or that network that connects the pop is what is referred to as what? Is what is referred to as the metropolitan area network, and then what? The long-haul network. Long-haul network is the one that connects what? Connects pops that are located what? Far away from each other. Metropolitan is the one that is what? The pops that are within the what? Within the metropolitan. Metropolitan, for example, Los Angeles. Clear? Now, in here, when you get to the metropolitan, the metro network or the long-haul network, we are talking about what? We are talking about optical networks, all of these that are used specifically, the DWDM. DWDM stands for the dense wavelength division multiplexing. When we are going to review when we are going to be talking about the layered architecture, this is a what? This is a physical layer. DWDM is a what? Is a physical layer. Now you might say, Professor, then what is the SONET? SONET is a physical layer plus what? Plus part of the second layer, layer 2. Whereas this one is strictly a what? A physical layer. Strictly a physical layer. Remember, when you talk about physical layer, we are not talking about what? Intelligence. We are talking about what? Transporting of the what? Of the bits. Clear transporting of the bits. So these are the access networks, the POPs. The POPs are connected to what? To the metropolitan area network through SONET links, for example, or point-to-point links. And these are the what? Metropolitans are connected to the long haul. You will see it here. Look at it. What we have. This is a metro link ring. This is a metro ring. All of these are what? Access network. Access network. Access network. Now, in here we learn a new word. I need you to understand it very carefully, which is called ADM. ADM stands for what? Add, drop, multiplexer. So ADM stands for what? Add, drop, mux. What does that mean? What does it mean? What are we adding? What are we dropping? It depends on the destination of the traffic. If the traffic, for example, is coming from this access, from this user to this user, yes, it will be dropped in here. And then what do we add in here? We add the traffic that is generated from these users that are destined to what? To other areas. Did you understand what I just said or not? Yes or no? Add the drop means what? Add the traffic that has reached the destination. No, I'm sorry. Drop the traffic that has reached the destination and add the traffic that is what? Generated. Clear? Generated at that point. So we do have an added drop mux located in what is known as a what? As a SONET ring. This SONET ring, by the way, is connected to yet another what? SONET rings, another SONET rings, another SONET rings. By the way, in the core, most of them are actually what? Point-to-point links, a mesh type networks. Clear? A mesh type network. Clear? And we will see why do we use a mesh and why do we use a ring later on in the semester. Clear? Clear? Okay, good. Now, the continued, again, the demand keep continuing for what? More bandwidth, more bandwidth, more bandwidth. Now, let's understand one thing here. SONET stands for what? Synchronous optical network is based on what technology? Based on the technology called what? TDM. TDM stands for what? Time, division, multiplexing, time division multiplexing. It provides for higher bit rate on the same what? On the same fiber. On the same fiber. On the same fiber for a higher bit rate by dividing the what? When I say higher bit rate on the same fiber, it means how many wavelengths? One wavelength, but I will be dividing it in what? In time. I will be dividing it in time. Clear? Now, what is the alternative to this? Alternative to this is to use what? More fibers to try to increase the bandwidth. To increase the bandwidth, what is one possibility? To extend more fibers, each one of them is time division multiplexed. Clear? But what is the preferable solution? The preferable solution is to use the what? The same fiber, but use how many what? We use what? Multiple what? Wavelengths. What is a wavelength? Let's see if you remember. What is it equal to? Anybody? C over what? F. What is the C? What is the F? Frequency. The higher the frequency, the wavelength will become what? Shorter and shorter. The wavelength will become what? Shorter and shorter. Clear? So the difference again, one more time. The difference between the WDM and the SONET, which is TDM based, is that in the wavelength division multiplexing, we are going to have multiple wavelengths on a single what? On a single fiber. And every one of these wavelengths could be what? Time division multiplexed. Did you understand what I just said or not? Every one of these wavelengths could be what? Time division multiplexed. In here we do have what? A single fiber. In here we do have what? Multiple fibers. Which one do you think a better solution? A better solution is to have a what? A single fiber with multiple what? Multiple wavelengths. That's the concept of the what? Of the wavelength. See this one here? We have a single fiber. How many channels do we have here? A single fiber. How many channels do we have here? We have 4 channels. Are you following or not? In here, what do we have? We have a single fiber, but how many wavelengths? 4 wavelengths, and each wavelength is divided into how many channels? 4 channels. Do you see the difference between this one and this one? This one is a question?
5-minute warning.
Okay, thank you. This one is a single fiber with what? A single wavelength, single fiber, single wavelength with how many channels? 4 channels. How many channels means what? When I say how many channels means what? How many users can it support? Are you following me on? 4. In here we have what? A single fiber, but how many wavelengths? Multiple wavelengths, and each wavelength is divided into what? Different channels, using what? Time division multiplexing. Clear? That's the concept of the wavelength division multiplexing. This is again another example. It's a fiber, we have multiple wavelengths. In here we do have only a what? A single wavelength. This is called what? SONET ADM. ADM stands for, one more time, add drop mux. This one is called what? DWDM, which is called what? Optical added drop mux. In here there is no changing in what? Electrical. Everything is done in the optical domain. In here there is a change between what? Optical, electrical, and then what? Optical. Clear? We will see that shortly. Clear so far? Okay. So this is what we have here. So we have multiple users here, for example. They will be time division multiplex on a single wavelength. This is one wavelength, another wavelength, a third wavelength. Every wavelength is divided into multiple channels, and then the wavelengths are multiplexed using DWDM to transmit it over a single fiber. This is a single fiber with multiple what? Multiple wavelengths. Clear? Clear? This is done where? This is done in the core network, in the core transport network. Clear? In the transport network. They are trying to extend this idea to the access network, but not to the residential customer, but to the what? To the corporate customer, because the corporate customer has higher demands. I want you to see the economy of the DWDM as compared to the conventional TDM. In DWDM, everything is what? Everything is fiber. So these OA stands for what? Optical amplifiers. We only need how many optical amplifiers in this case? Every 120 kilometer. Every 120 kilometer. Whereas in TDM, we need what? We need, because in TDM, you are going to what? Change from optical to what? Electrical. And then what? Optical. When you add and drop. Clear? In here, you are going to need a what? An optical amplifier every 40 kilometer. So in here, every three of these is corresponding to what? To one of these. You are going, in other words, instead of this, all of these things, you are going to use only what? Only one of them. How many fibers in here we are talking about? The same rate, by the way, is the same rate, 10 gigabits per second, for example. But in here we had how many fiber? 4 fibers. In here, how many fiber we have? Just 1 fiber. Clear? And reducing the number of optical amplifiers that are needed. Clear? You understand what regenerators means? Regenerator means what? Regenerating the signal as it's what? As it propagates over the fiber. This is again a sonnet ring, and they are connected via the backhaul. This is the long haul network via what? Via DWDM. DWDM is used in the core. The sonnet is used in the what? In the metros, in the New York City, for example, Chicago, and so on and so forth. I want you to get familiar with this notation. IP, what is IP stands for? Internet Protocol, running over who? PPP. PPP stands for what? The point-to-point protocol. Which layer is PPP? Which layer is PPP? Layer 2, which is the link layer, running over who? Sonnet. Sonnet is which layer? Physical layer. When it comes to here, what do you have? Sonnet is running over who? DWM, which means Sonnet is behaving as which layer? Layer 2 on top of what? DWDM, which is behaving as a what? As a layer 1, physical layer. Did you understand this terminology? Yes or no? I will study this in detail next time. Now, the next stage in the development is ignoring the Sonnet and integrating IP directly over what? Over DWDM. IP over what? DWDM. In this case here, you need to make sure that the router interfaces can support the higher rate of what? Of DWDM. Those router interfaces need to support what? Those higher rates. Clear? So we will talk about what? Notice, by the way, even though we say IP over... Yes? Okay. So we will talk about this later on. We'll continue it on later on. Clear? Okay. Now, don't forget, the discussion session will start tomorrow. So, Angelos will review some probability problems and so on and so forth to review your, to refresh your memory. Thank you, Jonathan. How are you, Angelo? Fine. Angelo, she has not decided yet on the other discussion session, so we will see how it goes.
But it's going to be here.
But tomorrow...
There is no change for that. Or no?
She did not get back to me yet, but there was operator today.
But
so,
I will come in this 122 room. Right?
No, I think your room is the other one. Is the 122.
Yeah, no, this one, 122.
The one is there.